This lab will focus upon the enumeration and exploitation of the intentionally vulnerable VM IMF, which is another Linux box you can find on VulnHub or my Google Drive. Download it, double-click the OVA to import it, change the network settings to host only, and let's get started. So just real quick, right-click IMF settings, go to network. As you see here, they have it set to bridged. We're going to set it to host only. Start it up, and after that, go to your Kali Linux box. Now let's use netdiscover to find the IP address. Okay, I got the IP address. Now let's hit it with nmap. Alright, we have a limited attack surface here, only port 80 open, Apache web server. So let's go open up Firefox and take a look at what we can find. Okay, before looking at it, I want to set up the proxy and open up Burp Suite. So, like we did before, open the menu, click Preferences, search for the proxy, go to your proxy settings, and you should already have that from the previous episode. Here's what it looks like. Port 8080, IP address is loopback, no proxy 4 box is clear. I just open up Burp Suite by clicking the icon over here. Temporary project, use burp defaults. I'm just going to turn intercepting off for now. Okay, now let's go to the IP address. Okay, we're at a home page here. Just went to projects. I'm going to view the page source. Okay, nothing interesting here. Go back. Go to the Contact Us page here. View the page source. See a flag here. It's encoded in base 64. Just going to copy that. Now go to Burp Suite and go to the Decoder tab. And you can paste in that base 64 encoded string. Now click Decode as base 64. You could also do it in a command line, but I'm just showing you a different way to do it. So we have something, all the files. So that could be something we need to know later. So just document that. All right, back to the web page here. Okay, I noticed these 3 JavaScript files. At first, I thought that this was a base 64 encoded string by itself, but it turns out that this is where it starts and this is where it ends. So you can just copy all that. I'm just going to open up LeafPad over here. Get rid of everything else other than the base 64 encoded strings. So this is all split up into 3 sections, but this is the base 64 encoded string right here. So same thing. Okay, so it gives us another base 64 encoded string, and that's the second flag. So I'm just going to copy that and put it up here. All right, now we have the plain text. IMF administrator. So we have 2 decoded strings, all the files, and IMF administrator. So those could be web directories. Let's take a look. Back to Firefox. First I'm going to try all the files. Okay, that's not a web directory. Now IMF administrator. Okay, so we get a login page. View the page source, see if there's anything interesting. Okay, we have a comment here. It says, I couldn't get the SQL working, so I hard-coded the password. It's still mad secure though. Okay, so they mentioned SQL. Maybe there's an SQL injection that we could use here. So let's try that out. Okay, so what I'm going to do here is turn on the Burp Suite Proxy Intercept. So you go to the Proxy tab, Intercept is on. Now I'm just going to put in test for the username and password, or let's try Jesse test, and click login. So we have two parameters here, the user and pass parameter. That is what we're going to send over to the intruder. And we are going to try to bypass the authentication using Sql injection. So clear all the parameters. We're going to set an injection point for pass. Now, payloads, I have a little list here. Here's some payloads that are going to attempt to bypass the authentication. So start the attack. Click OK. Let this thing run. You take a look at the response. So you get invalid username. And basically, if it is able to bypass authentication, we'll get a different response. I'm not sure what it is yet, but this is not the response we're looking for. You can sort it by length. That'll show you if there is a positive result, or you can manually look at them, but usually it'll have a different length if you succeeded. Okay, so after trying a good amount of SQL injection for authentication bypass unsuccessfully, I did some research and I found this OWASP article. It says that we can submit an array in the password parameter, or pass in our case, which is going to cause strcmp to think the password is null and allow us to bypass authentication. So strcmp is basically a function that compares two strings. Let's go back to Burp Suite and put this to the test. You got to make sure that your intercepting proxy is on. Just going to put in Jesse and test. You got that. Right click anywhere here, send to repeater. Okay. Now, exactly what they told us to do. Have these two square brackets before the equal sign and pass. Okay, that didn't work. Let's try a different username. Interesting. So it's not working. It has to be a valid user. Okay. So it's not working with incorrect usernames. Perhaps I need to use a valid user. I'm going to do a little bit more testing. Okay, so going back to the contact.php page, I noticed that we have 3 potentially valid usernames. We have R. Michaels, A. Keith, and E. Stone. So let's try all of these and see if we can get through here. First, I'm trying R. Michaels. Okay, now we've bypassed authentication. I see a flag here, and it's going to point us to cms.php, page home equals home. So let's go first to this base64 encoded string. Okay, it just says continue to CMS, so that's what we're going to do. I'm going to right click anywhere in here, request in browser, an original session. So we're just going to repeat this request in a browser. Let's clear this up a little bit. All right, now click this. All right, earlier they said we couldn't get SQL working in the HTML. So what I'm going to do now is intercept a request to this page and send it over to SQL Map so we can run a SQL Map scan and see if there's any directly exploitable Sql injection so we can dump the database. Let's go over here, back to the proxy. Intercepting is on. Now just reload that page to get a request going. Now we're going to use this page name equals home as the injection point. So I'm going to just go over here, and what I'm going to do is place an asterisk here in page name equals, and that's where all the SQL injections are going to hit. All right, so put the asterisk there. Now right click anywhere, and we're going to copy to file. I'm just going to name it SQLi2. Go to a terminal. Okay, the command is going to be SQL map -r. We're going to read the SQLi2 file that we just created. -risk 3, that's the max. -level equals 5, that's also the max. -dbs, we're going to be dumping the database if possible. And batch is going to say yes to everything, and we are going to give it multi-threading with 10 threads. Let's go. Very good. We have exploited an error-based SQL injection vulnerability and have dumped the admin database. Now I see down here there's a link to a .jpg file. So let's just copy that location. I'll minimize this for now, back to Firefox. So just right click and duplicate a tab here for the IMF administrators web directory, and we're going to paste that in. Okay. So let's just save that. All right, so let's take a good look at this picture here. There's a little box in the bottom left corner, and that is a QR code, and that can be decoded online. So I'm going to just open a new tab here and Google QR decode. Okay, looks like we're having some issues here, probably due to Burp Suite. Gonna have to show you how to fix that. So before you can access stuff on the internet while you're running Burp Suite, you're gonna have to do this. http://burp. Now we're gonna grab the CA certificate, save file, go to menu here, preferences. In the search box here, just type in cert. So bring you to the certificates that you have. And under authorities, you're going to click import and import that certificate that you just got from Burp Suite. Trust. Click OK. Click OK. Now there's one more thing we need to do. I'm just going to open up another terminal here and just exit out of Firefox because we're going to have to restart it anyway. So there's a bug when you're using Java 11, so we're going to have to change it to Java 8 in order to get SSL working properly. So update alternatives --config Java, and we're going to select 2, which is going to downgrade us to Java 8. All right. Let's restart Burp Suite. Restart Firefox. Okay. Back to the IMF administrator location. We're going to have to run that R. Michaels and password trick again. So just intercept a request to it. I'm just going to put it into the repeater real quick and put those square brackets here in the pass parameter. Make sure it's working real quick. Okay. So just request in browser in original session. Turn that proxy off. Oh. So you just go right in. Good. All right. Okay, let's try that again. So all I wanted to do was Google QR decode. And now we are able to do it with those minor changes. And I see this decoder online for barcodes. So let's go there first and see if that works. Okay, so what this does is it allows us to upload an image file, which is going to then be analyzed automatically for the QR code. So let's just browse it, go to your downloads folder, and we have whiteboard.jpg. Now submit query. Awesome. Right away we got the decode, and it's the fourth flag and a base 64 encoded string. So let's just copy that. We already have Burp Suite open, so go to the decoder and paste that decode as base 64. All right, looks like we have a PHP file, maybe another web directory, so let's just copy that back to IMF and duplicate a tab. Let's take a look. Okay, intelligence upload form. Okay, so my first thought is upload a PHP reverse shell. So let's go over to a terminal here. And I'm going to use a really cool tool named Weavly that is going to generate a PHP backdoor and try to exploit it. So let's go ahead and use that tool. Okay, so to do this, Weavly generate, then you pick a password. I'm going to name it Jesse. Then you pick a file name. I'm just going to name it backdoors.php. Okay, here it is. Now let's try to upload that. I'm going to have Burp Suite running so I can just see what it looks like. So we have browse. I have it in my root directory, and I named it backdoors.php. Here it is. So let's attempt to upload that and take a look at what transpires over the requests. So I have a post request here, a content type of PHP, and here's the payload. Let's see what happens. Okay, it says invalid file type. So clearly they have some sort of filtering in place that does not allow PHP files to be uploaded. Let's try to bypass that real quick. So let's do the same thing we just did. Upload. Okay, now down here at the content type, it specifies that it is a PHP file. So I'm going to just change that and name it image JPEG to try to trick the security mechanism. Alright, so that didn't work. We're going to have to find a different way to do it. Okay, so let's go back to a terminal. I'm just in the directory where I created the PHP file. I'm going to change the name of it with the move command to backdoors.gif. So we're going to try to trick the upload mechanism to think that it is a GIF file instead of PHP. So after we change the file extension, let's go in here with a text editor using V, and I'm going to add a GIF header with the hexadecimal value of a GIF header. And that should allow us to successfully upload this file. So save that. And we'll go back to the upload page and try this again. Good. File successfully uploaded. Okay, let's just view the page source real quick. And I notice a value here in the comments. So it's a little bit confusing and counterintuitive, but this value here is what the GIF file is renamed to after uploading it. And it's also in a directory that is called uploads. So I will show you how to exploit this now. Alright, so the command to directly exploit this is going to be another Weebly command. So we have the IP address, IMF administrator, uploads, and that unique value that was generated that we found in the HTML.gif. Right, so I need the password. So whatever password you created with that PHP file, there we go. Good. Alright, so now we have a limited shell. Right away I see a flag, so I'm just going to cat that flag. Another base64 encoded string, so copy that. If you still have Burp Suite open, just pop that into the decoder. Okay, we have a string agent services. Alright, so maybe a clue as to what we need to find here in the file system. Now I'm going to use a find command to search for the string agent and redirect the errors to dev null, which essentially blocks it from our view. So let's go to find /-name agent and this redirection to dev null so we don't see all the errors. Okay, I see a binary right here for agent. Let me just run it real quick. Okay, it's some custom binary and it is looking for an agent ID, which we do not know. So, some sort of reporting system. Let's go ahead and try to see what services are running. Alright, so netstat-ant. We're going to just take a look at the running services. We got MySQL, SSH, port 80. We already know about that, but here's one we do not know about, 7788. Let's take a look at that. I'm just going to use netcat and the loopback address, which is just the internal IP, and then the 7788 port. Alright, so connecting to that port tries to access this binary, this IMF agent reporting system, which is the agent binary we saw earlier. So we did not see that port running when we ran the nmap scan. Now let's go to the user local bin directory, see if there's anything else that's useful here. That's where the agent binary is. Okay, so I see the agent binary and I also see a file called access codes. So I'm just going to cat that real quick, see what's in it. Alright, we have 3 numbers separated with commas. I can only guess that these are port numbers. They look like port numbers, but it's actually a number sequence that can be utilized for port knocking. So what is port knocking? It's a methodology that allows us to access inaccessible ports by sending certain connection attempts. We can automate this with this tool Knock that I'll get from GitHub, and I'll show you where it is. So first of all, let's just close out of Burp Suite. We don't need this anymore. I'm going to also turn off the proxy. So just no proxy. All right. So here's the GitHub page for Knock. I'm going to clone it. So just grab the clone URL here. Just type git clone and paste in that URL we just got from GitHub. Good. I'm just going to go to that Knock folder. Okay, so what we're going to do here is run Knock. We have the IP address of IMF, and we have the 3 numbers that were retrieved from the access code files. So this should open port 7788. Okay, so let's verify that port 7788 is now open. So nmap -p 7788 and the IP address of IMF. Very good. So we've utilized port knocking to open port 7788. Now I want to grab the executable, ship it over to Kali Linux, and find out how it works, see if we can exploit it somehow. So first I want to download and install RetDeck, which is a very cool decompiler that's going to automate a lot of the analysis for us. I'm going to show you where to get it and how to install it. So let's go over to Firefox. Just open up a new tab here. I'm going to show you the GitHub location. Alright, so go to GitHub, here it is, and we're going to clone it, same as before, so grab that clone URL. Back to our shell, I'm just going to go to my home directory, and we are going to type git clone, and then the URL that was just copied. Okay, that's the first step. It says, couple things we have to do here. It's going to take a little bit of time. So first I'm going to install the dependencies. I'm going to show you that now, and I'm going to also have all of these commands listed in the text file that's attached to this lecture. So let's just install all these dependencies. Yes to everything. Okay, first off, we're going to change directories to RetDeck. We're going to make a directory called build and change to that directory. And now we're going to prepare the make and install. So we have, this is going to be the location for the installation, which is home and RetDeck. Should be the same for you if you followed my tutorial here. This whole process takes a little while. Now we're just going to run a make and make install. Okay, after that is finally downloaded and installed, let's go over to the Weebly shell, and we're going to use a command :file_download. We're going to specify the location of the agent binary, and also specify the location where we want to put it in Kali Linux. So I have here the RetDeck binary location where we're going to run the binary against the agent binary. So let's run that command, and now go back to Kali Linux where it is downloaded. Here's the directory where I put it, root RetDeck bin. Here it is. Okay, so now what we want to do is run the RetDeck decompiler, which is right here. I'm just going to type in // the name of the Python decompiler that we're going to run, and agent. All right. So that has decompiled. And now you see here we have a bunch of files which were created as a result of the decompiler running against agent. So now I want to take a look at the contents of these files here. Okay, now I'm going to run cat agent star. That's going to cat all the files that start with the name agent. And then I'm going to pipe that to less and use the SR switch to remove carriage returns. And we will go down a couple lines here. Okay, I see the functions. Now let's take a look at this. Okay. So, the agent ID is going to rely on this right here. This hexadecimal is where the agent ID is hard-coded. So, let's take this string and we're going to decode that or convert it into decimal. So we could do that on command line. We'll just exit out of that. And I'm going to do echo $, and then close that. Okay. So we have the decimal representation of that string that was hard-coded into the agent binary that we just decompiled. And I am now going to try to use that to enter in as the agent ID. So chmod plus X, we're going to make agent executable. Okay, now it's asking us for the agent ID. I'm just going to plug in that value. Okay, now we have authenticated into this binary. Now it has 3 different options. One of the options is to submit a report. Let's try that one. Okay. And you just put input, so it accepts input into this report function. Let's try sending a bunch of characters to it and see how it reacts. We're going to create 200 A characters with a quick Python code here. Print A times 200. So it's just going to create 200 A's. All right. First of all, we're going to enter in that agent ID. And now submit report with the 3 option. And I'm going to plug in those 200 A's. Okay, look down here. We have a segmentation fault. So if you're familiar with my past courses, you know what this means. We're going to have to create a custom buffer overflow exploit. And since we have remote access to the service, we could potentially get a nice reverse shell with elevated privileges. First, we're going to have to run a Ruby script called pattern create to generate a unique pattern of 200 characters, because that's how many characters it took to crash the application. And we're going to find the extended instruction pointer, or EIP, which is going to tell the binary which command to execute next, and it is necessary information to exploit this binary. So we're going to type in locate pattern _ create. And here it is. Just plug that in. Specify a length of 200. Okay, now I'm going to use GNU Debugger, which is a command line debugger that is built into Kali Linux, and I'm going to type in agent. That's going to start the binary agent with GNU Debugger. Now we're going to run the binary, and we know the agent ID now, so we can go in there, submit report, and we are going to plug in that string of 200 characters here. Okay. So now we know the value with which the EIP was overwritten, which is right here. So we need to document this information and keep on moving. Now we're going to use pattern offset to calculate the pattern offset, which is going to be shown to you right now. So locate pattern underscore offset. And we are going to use that value which was just discovered with the -q switch, and it is going to calculate the pattern offset. Okay, we have a pattern match of 168. Armed with this necessary information, let's continue our exploit development. First, we're going to have to create some malicious shellcode with MSF Venom. So I have this command here. We're going to use a Linux reverse shell payload, which is in the 32-bit architecture. And we have our local host, which is going to be the Kali Linux IP. And we have the local port, which is going to be 4448. A format of Python, and we are specifying some bad characters. So we haven't actually searched for bad characters for this particular binary. However, we know that the null character, or x00, is always bad. And these are commonly bad, which is the 0A for a line feed and a 0D for carriage return. So we're just going to specify those as bad characters and create our malicious shellcode with MSF Venom. Okay, now what we're going to do is use objdump and try to find a vulnerable JMP or call to execute shellcode at EAX. This is necessary, otherwise we will not have an address to instruct the binary to execute our shellcode. So what we're going to do is type in objdump -d, name of the binary, which is agent, and we're going to pipe that to grep and search for JMP, then pipe that to another grep, searching for EAX. Okay, no luck there. Let's change the JMP to call. All right, we have an address here. Now we can use this address and reverse it and put it into bytecode format in order to instruct our exploit to execute shellcode at that specific address. So I'm going to show you exactly how to do that. I've already written up a Python script which is on my GitHub page. So I'm going to walk you through how to change that in order to get it to work for you. Okay, so jump over to Firefox real quick. Here's my GitHub page. I have a Python script called agentsploit. So I'm just going to view that in raw, copy that, and we are going to just make a new file, agentsploit.py. Paste that in there. Let's take a look at this. So we have the 168 A's minus the length of the buffer. I'll go up a little bit. So you're going to have to replace this with the shellcode that you have generated. And I already have the address here that was converted. The call EAX address, it was converted from the format that we discovered with object dump, and it has been reversed, as you can see here, and converted into bytecode. Now we have some arguments, which are going to be the server and port. So we can just specify the target and the port, which is going to be 7788. And I've created some sconnect here. So sconnect, it's first going to ask us for the agent ID, which I put here. So it's going to automatically enter the agent ID. It's going to receive response, which is going to ask us for which entry we want. And that's going to be 3 to choose to submit report. And then it's going to send the buffer, or send the buffer overflow. And that should get us a reverse shell. But first, obviously, we need to have netcat running. So let's do that first. Actually, I'm going to have to replace the shellcode because this is going to be different for me as well. I have a different IP address. So I'm just going to use gedit. All right. So just remove that and replace it with MSF Venom's output. Save that. Okay. Now let's get another terminal going. I'm going to type in nc-nlvp4448. Okay, so What we want to do here is Python agentsploit.py, IP address of the target, and the port was 7788. So this should exploit the buffer overflow exploit that we have done locally over the wire, because now we have opened that port with port knocking, and we have the listener over here. Let's see if it works. Perfect. So now we have a root shell. Let's go ahead and use our trusty Python code to make a TUTY shell. Oh, interesting. So that did not work. Let's try. That didn't work either. So it's giving us some problems here. Let me see. All right. Fair enough. We'll use that. So anyway, let's go to root, and we have our flag and something called theend.text. Very good. Just for fun, let's see what is in this base64 encoded string. We can just do that with command line. Ghost protocols. Okay. Well, we're done here. Got root privileges, and we are ready to go on to the last lab.